A filament lamp converts electrical energy to light. When we connect a lamp like this in a circuit, the current flows through the filament wire found in the bulb. This causes the filament to heat up and glow, which is how we produce light using the electric current. Now, you don't need to understand the details of how lamps work for your exams, but you do need to be able to recognize and analyze the IV graph for one. So how does this look? Well, the IV graph for a filament lamp is curved. Remember that IV graphs show us the relation between current and potential difference for a component, with current on the y-axis and potential difference on the x-axis. For a filament lamp, the graph would look like this. It's roughly straight in the middle for low potential differences, and then it curves down as we get to higher potential differences. This pattern is the same when reversing the current to get negative values, so it doesn't matter which way we connect the lamp. But since the graph is curved, this means the filament lamp is a non-ohmic conductor. Remember that ohmic conductors have constant resistances, and they have straight IV graphs to show current and potential difference are proportional. But here, the lamp is non-ohmic and the current and potential difference are not proportional. Instead, as the current increases, the resistance increases. Remember that the gradient of an IV graph tells us the resistance of the component. But steeper gradients don't mean larger resistances. Instead, a steeper IV graph means a lower resistance. Since the gradient here is current divided by potential difference, we're finding I over V instead of V over I. For the lamp, we see that near the origin, in other words, where the current is small, we have a relatively steep gradient. So for small currents, the lamp has a low resistance. But at the ends of the graph, where the current and potential difference are high, we see that the graph is nearly horizontal. In other words, it has a very small gradient and so a very high resistance. This means that as we increase the potential difference, we wouldn't see much change in the current. But why does the resistance change? The resistance of the lamp changes because larger currents cause the temperature of the filament to increase. Remember that the lamp works because of heat building up in the filament. Then as we use a higher current, we'll get a higher temperature in the filament. This then causes the lamp to have a higher resistance. You don't need to know why this happens at GCSE, but make sure you can recall that the increase in resistance is caused by this increase in temperature.
Thanks for watching. If you want to take your GCSE revision to the next level, head over to launchpadlearning.com and check out our smart learning platform that's been designed to get you top results in your exams. We cover your whole specification and make revision fun with interactive quizzes, easy-to-follow videos, and more. You'll be kept motivated by your own AI tutor who's here to support you every step of the way. To check it out for yourself, click here. Or click here to keep watching a selection of the videos from our full GCSE Physics course. See you there!